Hello there, fellow math enthusiasts. Mrs. Delzati here. Today we're going to go ahead and work on solving quadratic inequalities, both algebraically and by graphing. So first thing that I would like us to take a look at. For each of these graphs, I want us to write a compound inequality for the values of x, where the graph is above the x-axis, and I want to figure out what kind of y values, whether they are positive or negative, do they go ahead and correspond to. I want to do the exact same thing for when x is below the x-axis as well. So let's go ahead and let's start with above the x-axis. If I look here, the graph is above the x-axis here and here. If I bring that down to my x-axis here, I am seeing that for values below -2, so x being less than or equal to -2, or for x being greater than or equal to 5, the graph is above the x-axis. When it's above the x-axis, I'm talking about some positive y values. All right, now let's go ahead, let's do the same thing when we want below the y-axis or below the x-axis. Well, below the x-axis is right here. This translates to this part on my x-axis, which means if I'm talking below, I want the values in between -2 and 5, which means I have -2 is less than or equal to x, which is less than or equal to 5. This right here, this is representing our negative y values. All right, let's think about the same thing with number 2. Number 2, I want to know, first of all, where is it above the x-axis? Well, above the x-axis, that's this part right here. If we think about that on our actual x-axis, that is in between -3 and 7. And I'm seeing that these are positive y values. And then if I want to know where it is going to be below that x-axis, well, I'm looking at this part right here, which translates to that on the x-axis, and this part right here, which translates to that part right there on the x-axis. So I want the values that are less than or equal to -3 or greater than or equal to 7. And this right here, these are going to be our negative y values. All right, now let's go ahead and let's see how this is going to translate to solving a quadratic inequality by graphing. If I have the inequality x squared minus 6x plus 5 is less than 0, this means I want the values to be smaller than 0. I want my y values to be smaller than 0. Well, being less than 0, those are negative values. And the negative values we know are below the x-axis. So as we go ahead and we graph this here, if I plug this into my equation, x squared minus 6x plus 5, I'm going to go ahead and graph that. And I'm going to do a quick sketch of that. All right, that looks something like this. Now I'm going to go ahead and I'm going to use some open circles since it says less than. I have this value, and I want to know where it goes below the x-axis. Well, that's this section that is in between here. Now I need to be able to figure out what those coordinates are. So what I'm going to do is I'm going to find my intercepts. Second trace, I am looking for my 0. I'm going to click enter once. I'm going to move to the right side, click enter again. And then I'm going to go ahead and take a guess. And I see that one of my zeros is at 1, 0. And then I'm going to go ahead and do it for the second one, second trace, looking for my 0. I'm going to arrow so I am on the left side of it and click enter. And I'm going to arrow so I am on the right side of it and click enter. And then I'm going to take a guess. and I see that my other 0 is at 5, 0. So I'm only concerned about my x values here. This told me when my y values were going to be negative, but my answer is in terms of x. I am seeing that this happens between 1 and 5. So I've just gone ahead and I've solved this graphically. Let's go ahead, let's take a look at number 4. 2x squared plus 3x minus 3 is greater than or equal to 0. Well, if it's greater than or equal to 0, I want positive values. I want to know when the graph is above that x-axis. So let's go ahead, let's graph this equation. I have 2x squared plus 3x minus 3. I'm going to go ahead and graph that, and then I'm going to do a quick sketch of it. Look something like this. Since it's greater than or equal to, we're going to have closed dots on it. And I want to know when it is above the x-axis. Well, it's above the x-axis in this left-hand section. So I'm going to shade to the left. It goes below it, so I don't want that section. And then it goes back above it as I move off to the right. Now I need to use my calculator to go ahead and to find those two x-intercepts. So just like before, we're doing second trace. We're trying to find our 0. I'm going to arrow to the left of it and click enter. I'm going to go ahead, arrow to the right of it and click enter. I'm going to take a guess, and I see that my 0 is at negative 2.1860. And then I'm going to go ahead and do the exact same thing on the right side. I'm going to do second trace. I'm going to arrow so I am on the left side of it and click enter. Oops, let's try that again. Second trace, 0, arrow to the left side of it and click enter. Arrow to the right side of it and click enter. And then I'm going to go ahead, take a guess, and I see that I'm at 0.6860. So if I would like a compound inequality that deals with this situation here, I have either x is going to be less than or equal to a negative 2.186, or x is going to be greater than or equal to a 0.686. All right, so what we're seeing here too with these two examples, when we have the center section, we can write it as one compound inequality. When we have the two outside sections, the compound inequality is going to be an or statement. All right, let's go ahead and let's flip it over and let's think about some special cases here. For this first one, I have ax squared plus bx plus c is less than 0. If it's less than 0, we want the negative values. We want the part of the graph to be below the x-axis. Well, if I look at this, when does that actually happen? This graph is never going below the x-axis here, which means this graph, this inequality, is going to have no solution. Now, if I take a look at part B, this ax squared plus bx plus c, this is my graph right here. I want it greater than 0, which means I want positive values. I want it to be above the x-axis. Well, looking at my graph, isn't this graph always above the x-axis? And in this case, since it is always above the x-axis, we're going to have the set of all real numbers. All right, look at part C. Ax squared plus bx plus c is going to be less than or equal to 0. So that means I want it to be negative, or I want it to be 0. If it is negative, it's going to be below the x-axis. If it is 0, it is going to be on the x-axis. Well, if I take a look here, it never falls below, but it does go ahead. It does touch the x-axis there. It's touching it at the vertex. Keep in mind our vertex is HK, and since we're concerned about our x values, we can say x is going to be equal to h. All right, look at D. Ax squared plus bx plus c, I want it to be greater than 0. I want it to be positive. And if it's positive, that means it is above the x-axis. It does not mean that it is touching the x-axis. We'll notice right here again, it is touching the x-axis. It is happening at HK, and again, we're concerned about our H value. All right, which means we can go ahead, we can say everything, but we can't have H. In this case, we can write down that X is not going to be equal to H. All right, so just some special cases there. Now let's go ahead, let's take a look at an application of this. Number 5 says, suppose a study was conducted to test the average reading comprehension of a person X years of age. The study found that the number of points P of X scored on a reading comprehension test could be modeled by the following equation, where 5 is less than or equal to X, which is less than or equal to 95. This right here, this is our domain. Now it says at what ages does the average person score greater than 60 points? Let's think about why we have that domain there. If we're going 5 to 95, can a 2-year-old necessarily read? Probably not. So we're going ahead and saying that the minimum reading age is 5. Why is the maximum age 95? Do we have people who are living to 200 years old? Probably not, which is why we're cutting off that maximum age at 95. Now, we want this equation, this negative 0.017x squared plus 1.9x plus 31. We want to know when was this going to be greater than 60 points. So if I put my 60 in for P of X there, we're going to say 60 is less than that negative 0.017x squared. This value right here, this is greater than it. We want this to be above 60. So to do this, we're going to go ahead, we're going to put this into our calculator. I'm going to clear out y equals, and I'm going to do a zoom 6 because something happened with my last screen just to get it back to that nice 10 by 10. And into y1, I'm going to put that equation, negative 0.017x squared plus 1.9x plus 31. And into y2, I'm going to go ahead and put in 60. Now, if I graph this, I'm not seeing anything right now. But if we think about this, all of this stuff is happening a lot higher in that first quadrant. So I'm going to go ahead and change my window. I know my x min to x max, I was going from 5 to 95. That was what our domain was. So just to make sure I can see everything, I'm going to go 0 to 100. And I'm going to put my x scale at 10. Now my y minimum, I'm going to go ahead, I'm going to leave that at 0. And I want to know when was it bigger than 60, so I'm going to put that at maybe 100 also, and change my y scale to 10, and see if that's a good graph. I'm seeing that it is here. So because I'm using my calculator to do all of the work, I'm going to go ahead, I'm going to sketch out a graph here. I know that these here, these are going to be open dots, and I want to know when is it going to be greater than 60. Okay, so here is my line of 60. I want it above, which means I want this part of my graph. I need to go ahead and find those two intersections. So second trace, number 5, I'm going to arrow over close to the left side. I don't have to get on top of it. I can get close to it. Take a guess, and I have 18.240. And then 60. I'm going to do the same thing with the second one, second trace. I'm looking for the intersection. I'm going to move on over, get close to it, enter 1, 2, 3 times, and I see that I have 93.525. All right, so I can go ahead and I can say, well, in between these ages, 18.240 is less than x, which is less than 93.525. What this is representing here is that between these two ages, the people would go ahead and would score greater than 60 points on it. Now we do have a couple more problems to take a look at, so go ahead and find me part 2, please.